Imagine every device on a network as a house. Just like each house needs a unique street address, each device needs a unique IP address. In the world of IPv4, we work with 32-bit addresses made up of 4 octets. Getting familiar with address classes, private ranges, and special addresses is key. Think of it as learning the neighborhood layout before you start exploring. Understanding these fundamentals is essential as you dive into subnetting, routing, NAT, or ACLs. You can't build a solid network foundation without mastering IPv4 addressing first. Let's talk about IPv4 address classes. Imagine them like sections on a restaurant menu, each with its own distinct purpose and appeal. Class A is the oversized family pizza on the menu. Its addresses range from 1 to 126, sporting a 8 subnet mask. This setup means 1 octet is for the network and the other 3 are for hosts. Picture inviting 16 million devices to your network bash. Then there's Class B, your medium-sized pizza option. It covers address ranges from 128 to 191 and comes with a /16 mask. This means 2 octets for the network and 2 for the hosts, allowing for a snug fit of 65,534 devices. Class C is like your personal-sized pizza, perfect for a small get-together. It uses addresses from 192 to 223, paired with a 24 mask. Here, 3 octets are dedicated to the network and 1 for hosts, giving you room for 254 digital guests. Class D, that's the party platter meant for multicast, with addresses from 224 to 239. And finally, Class E is the mystery dish, set aside for experimental use, ranging from 240 to 255. Think of it as the chef's secret special, not listed on the main menu, but full of potential surprises. RFC 1918 gives us these 3 private address ranges that are like hermits. They just don't venture onto the public internet. They're not routable out there. First up, we've got the Class A private range, which starts at 10.0.0.0 and goes all the way to 10.255.255.255. That's 10.0.0.008 if you're into the shorthand. Next, there's the Class B private range from 172.6.0.0 to 172.31.255.255 or 172.0.0/12. And finally, the Class C private range 192.168.0.016, which might just be what's keeping your Wi-Fi humming at home. Now, if private addresses want to mingle with the internet, they need a chaperone called Network Address Translation, or NAT for short. Public addresses, on the other hand, are doled out by folks like IANA and ISPs, and each one has to be as unique as a snowflake on a global scale. An IPv4 address is like a 32-piece jigsaw puzzle split into 4 8-bit segments, and we call these segments octets, which we write in dotted decimal format. Now, turning binary into decimal is a bit like looking at a menu where each item has a fixed price: 128, 64, 32, 16, 8, 4, 2, and 1. You simply add up the prices wherever there's a 1 on the menu. Let's use 192.168.11 as an example. The first octet, 1100,000, is like ordering the 128 and 64 options, which adds up to 192. The second octet, 10101100, means you're selecting 128, 32, and 8 from the menu, totaling 168. Getting familiar with these powers of 2 from 128 down to 1 is vital, especially when you start tackling subnetting calculations. 5 IPv4 traps you might walk into on the exam, so keep your eyes peeled. First off, the 127.008 range isn't just about 127.0.1. It's like the whole loopback section. Imagine it as a private booth in a restaurant where the server chats with itself. Next, we've got APIPA, the 169.254.0/16 range. If you see a device with a 169.254.xx address, it's like being served a default meal because the chef, or rather the DHCP server, didn't send out a specific order. Third, Class D is all about multicast. It's a party zone, not a place for individual hosts to live. Fourth, don't forget about the network and broadcast addresses. They're like the crusty ends of your subnet sandwich, not meant to be used by the hosts, so always remember to subtract 2 when counting available addresses. Lastly, 172.160.0.0/12 isn't just about 172.x.x. It actually stretches all the way from 172.60.0.0 to 172.31.255.255. It's a much larger playground than most folks expect. And that's a wrap on IPv4 addressing, covering everything from address classes and private ranges to those quirky special addresses and binary conversions. These fundamentals are like the bread and butter of CCNA exam questions. For more practice, hop over to Courseiva.com. Keep pushing forward. You're doing great.